Hey guys, welcome to another set of videos from EcoPoint. Today I am starting off with the topic of linear algebra, and in today's lecture we will just try to understand what is linear algebra, what is the base for linear algebra. Okay, so it'll be a quick brush up of linear equations because that is what linear algebra is based on. But yes, it's much beyond linear equations. So let's start with the idea of an equation. The word equation, what is it telling you? That you have two mathematical terms, two mathematical figures, and they're equal. So equation just means that you have something you can equate. So you have two terms you can equate. For example, as you can see on the screen, a very simple example, if I have 4 times x is equal to 8, this is an equation because you can see that equal to sign out here. Two mathematical terms are there, 4x, 8. Intuitively and algebraically as well, you can clearly state that, okay, this means x should be 2 because x, when I give value 2, 4 times x will give me 8, right? Now, let's extend this idea. This was one piece of information that I had, right? अब इसको information की तरह से बोलते हैं. Let's take a practical example. Suppose I wish to go out today with my friend, I want to eat out somewhere. So I decide to go out with my friend and I decide to buy 2 drinks and 2 burgers along with it, and I paid £3 for it. I'm taking pounds because it'll be easy for us. We don't have to write down in hundreds. So I buy 2 drinks and 2 burgers and I pay £3 for that. This does not tell you what is the individual cost of a drink, and it doesn't tell you what is the individual cost of the burgers, right? If say the individual cost of drink is x, okay, x is the cost of one drink, okay, and y is the cost of a burger. In that sense, I can create an equation with this information given to me. I can say, okay, that means what is happening here is that 2 times x plus 2 times y cost me 3. So 2x plus 2y is equal to 3, right? This is what you get from here. Now, I just had one piece of information. With this one piece of information, I can write it down as an equation, but I do not have any one particular solution to this. I will not be able to tell you that, okay, the drink was for this much and the burger was for this much. Okay, per se, I know about it, but maybe you, if you are trying to calculate, you would not get to know. But in case I add some more information to this, it's impossible for us to find a unique value for the price of each commodity out here. But if I increase the information, I add some information. Suppose I get to know from you that you had to pay for 2 drinks and 1 burger. Yesterday, you paid 2.5 pounds. So this is an added information that we have. And in terms of x and y, I can depict this also as an equation. And this equation is 2x plus y equals to 2.5. Now what is happening? Now you have 2 equations in 2 variables x and y. Because you have 2 equations in 2 variables x and y, after looking at these 2 equations without solving, you will be very easily able to find out how much individual burger and drink cost you. With this, we have created an equation and we will be able to solve this problem. If 2x plus 2y was equal to 3 and 2x plus y is equal to 2.5, clearly x must be just 1. So the drink is for £1 each, and clearly y, that is the burger, is for half a pound. And that made you pay £3 in total. If you take that value, x as 1 and y as 0.5 without any calculations, you can find this out, and you can, if you put in here, it'll be 2 into 1 plus 0.5, that gives you 2.5. 2 into 1 plus 2 into 0.5 gives you 2 plus 1, that's 3. And you have your answer. Of course, this was a very, very simple example, right? It was a very simple example to understand. What I'm trying to tell you here is that equations are nothing but it's some information which could be depicted with equal sign. That means some information here is equal to something that you know on the other side. So this was very simple, but in general, in engineering problems or some, other subjects, quantum mechanics, or so many other different branches are there for that matter. In real, these problems could be really complicated. The variables could be too many to handle, right? So this would need calculations. This will definitely need calculations out here. Linear equations are basically equations where the variables that you are taking up in the equation have power of exactly 1. So you will not find x square, y square. No, those are not linear. Linear equation would contain x, y, z, and so on and so forth. Variable name could be anything. But yes, the power of that variable will be 1. Okay. Now, what we created in the previous example, I started with one equation. What I did, I added information and I was able to create another equation out there. Now, those were two equations. So when you have more than one equation, it becomes a system of equation, or we call it linear system or system of linear equations. It's one and the same thing, whether you call it linear system or system of linear equations. It's basically a set of linear equations. What are we interested in? What were we interested in? We were trying to find out the value or the cost of the individual cost, basically, of the drinks and burgers. Similarly, we are in general, when you have linear equations, you are interested in solutions. So in the previous example, we got exactly one solution. That's called unique solution. That's called unique solution. You can have a unique solution or you can have multiple solutions. There could be a scenario where you have no solution at all. Now, how will you find out these solutions? It was very easy in that example, but every time that will not work, right? So linear algebra is basically, a systematic exploration of linear equations. And this process is related to arithmetic of matrices. And that is why matrices and the knowledge of matrices becomes very important when you're working with linear algebra. My task here would be to take you through in linear algebra. I would need the little bit knowledge of matrices, but I will keep on doing the basics here as well. Now, linear algebra goes beyond solving linear equations. We will be talking about vector spaces as well. We will be talking about everything around vectors, around the vector spaces. Okay. Now, what is a general form of linear system or system of linear equation? So you saw what we created. We created 2x plus 2y equals to 3. 2x plus y equals to 2.5. Similarly, there could be many equations in many variables. So how do you depict it? A general form would be a11 x1 plus A12 x2 plus A13 x3, so on and so forth. And say you have how many variables? X1, x2 till say xn. That is, you have n variable case. So you will go on till A1n xn and it is equal to say B1. Similarly, there is another equation A21 x1, A22 x2 plus A23 x3, so on and so forth. A2n xn is equal to B2. Now say you have m equations. If you have m equations, so you move on till am1 x1, variables are n, okay? So it's just that you have m equations, so am2 x2 plus so on and so forth till amn xn is equal to bm, because there are m equations. Now the same thing could be written in terms of a matrix as well, which I will talk about a little later. And now I would like us to solve a set of linear equations. So now this time I have an example where we have three variables and three equations. So when you have a linear equation in three variables like x plus 2y plus 4z equals to 7, when you create a graph, the graph is a 3D graph, okay? It's a 3D graph. You have three variables. So it's a 3D graph. And had it been just two variables, anything with two variables gives you a line. And anything linear, a linear equation that is in three variables, and that too in three variables, that will give you a plane. So we have three equations, x plus 2y plus 4z equals to 7, 3x plus 7y plus 2z equals to minus 11, 2x plus 3y plus 3z equals to 1. If you graph it, of course, I have taken the help of a software to graph it, and this is what the graph looks like. You can see from the graph also, there must be some intersection out here. There is some intersection where all three of them are intersecting. So there are individual planes out here, the three equations that we have mentioned. So they are depicted by these three planes. Graphically, it looks like this. And for solution, I will have to solve. There could be different ways of solving. If I know nothing, if I know very basic level of algebra, what I can do is I can, from three equations, I can keep on substituting and I will get my answer. So what I can do is I can take up two equations at one time. So this and this seem to be very simple equations. So if I take 1 and 2 or 1 and 3, what I can do is I can eliminate some variable. I'm eliminating x out here, and I can get a simplified version here. So what I have eliminated x by multiplying the first equation by 2. And then when you subtract, you will get y plus 5z equals to 13. So you have made, what you've done here is the task was to get it in one variable, in two variables, get rid of one variable. And similarly, just use the first and second equations. And now again get rid of x and get another equation in y and z. Once you do that, you get another equation. As you can see, minus y plus 10z equals 32. Now I have two equations in y and z. Minus y plus 10z equals to 32. And 5 plus and y plus 5z equals to 13. If you subtract, you don't have to subtract, you have minus y, so you can just add, just add, and you will get 15z equals to 45, which means z is equal to 3 clearly. Now, the moment you have z equals to 3, you can find out y from any one of these, right? You can find out what y will be. Y is 13 minus 5z, so you get that y is minus 2. And once you have y and z, put it in any one of your equations out here, you will get the value of x. X is, so what we have done is we've just back substituted. We've just simplified and back substituted. You can do this. If you know nothing else, you can definitely do this, right? This is giving you a unique solution. Again, what we have is a unique solution. There would be a point here where all three of them are meeting. Okay, all the three planes are meeting at one particular point. So what kind of solutions can we have? We can have unique solution. We can have multiple solutions. Multiple solutions, we call it infinitely many solutions, because when you have multiple solutions, that generally moves on to infinity. You can have a situation where you get some kind of inconsistency. Inconsistency would lead to no solution. So I'll give you examples here with two equations and two variables. So for a no solution, basically, what is the meaning of solution? If you have two equations, your solution means something that satisfies both the equations, right? So it will be a point of intersection. So think about it. If you have no solution, that means the two lines are not meeting anywhere, or the planes are not meeting anywhere. All of them are not meeting. Okay. So for example, parallel lines. When your equations given to you are parallel lines, they will never meet each other anywhere, and hence that will be a scenario for no solution. Now, infinitely many solution means whatever number of equations you have. It could be more than two equations also, okay? It could be more than two equations also. Or in case of, for example, we took three variable, three equation case. So if it is three variable, three equation case, so infinitely many solutions means that no matter which point I take, it satisfies, if it satisfies one, it satisfies all. That means that you have like overlapping. So overlapping as in that if you take 2x plus 3y equals to 6, graph it, and then take 4x plus 6y equals to 12, the graph will be the same. It's an overlap. It's just the same line. Okay. So that's infinitely many solution. Now, whatever is satisfying this, there could be infinitely many points satisfying this. Now, those points satisfy the other also. So this is what is infinitely many solutions. Okay. In case of plane, they are again overlapping planes. In case of no solution, if you want to, imagine 3D, in 3D, it could be, say, two planes are parallel, or, there is an intersection of the two, but the third one is parallel. So when you're looking for solution means whatever points you are getting, it satisfies every equation in the system. It should not be the case that it's satisfying one, it's not satisfying the other two. No. Solution, a point is a solution when it satisfies each and every equation in the system of equation. Now, no solution is a scenario where you get inconsistency. So you call the system is inconsistent, or you call this scenario inconsistent. So inconsistent goes with no solution. Consistency goes with, if your system is consistent, it's written, then that means it has at least one solution. It could be a unique solution, or it could be infinitely many solution. It could be either of the two cases. Okay. Now the same system of equations that we saw, okay, in this question, you had three equations, three variables. Now the same could be depicted in a matrix formulation. Today, I will end my video by just putting it in matrix formulation and guiding you how to solve it. Now, A is your coefficient matrix. A is the coefficient matrix. So in a coefficient matrix, the first column that you see, it would contain all the coefficients for x. In the coefficient matrix, the second column is with all the coefficients of y. The third column, all the coefficients of z. Now, why it's like this? Because what you are doing is, this is a matrix consisting of coefficients like this. Here, you have a column vector. It's called a column vector, x, y, z. So when you multiply, you need to know matrix multiplication. So 1 multiplied by x plus 2 multiplied by y plus 4 multiplied by z equals to the first position, of course, because it's the first row getting multiplied. So first position, that is 7. If you observe, that's nothing but your first equation. Similarly, second equation, again, if you multiply like this, you will get your second equation. So matrix multiplication goes like this, inverted L. Right? Now, how do you solve a system of linear equations using matrix? You use the augmented matrix. You will use augmented matrix. Here you will have the coefficient matrix, and here, this B, you will add another column. Add another column with this slash, just so that whatever operations you use on the left hand side, you're also using it on the right hand side. Now, when I say operations, what do I mean? There are some row operations. What are the row operations? Elementary row operations. You can swap any two rows. So when you're swapping, just be careful. When you're swapping the left hand side, you have to swap the right hand side. Otherwise, it destroys the given equation, right? So you can swap, you can scale up, you can rescale and add. Now, what do you mean by rescale? Rescale means you multiply an equation by a non-zero scalar. So that's rescaling. So for example, I can create like twice of R1. For example, I can create twice of R2. Okay, if need be. Okay. And then with the elementary row operations, you can, by rescaling, adding, you can create a scenario where you will be able to find out the solution to this system of equations very easily, which is something that I will cover in my next lecture. Thank you very much for watching.